This experiment investigates the centripetal force. So that's the force that's acting towards the center of a circle, and the period, that's the time taken to do a complete loop. Note that the speed is constant and the force and the acceleration is acting towards the center. Note that I have used the word speed because velocity is not constant, because the direction is always changing as this object goes all the way around. So it's continually changing. Since velocity is a vector quantity, since the direction is changing, the velocity is changing and it's accelerating towards the center. So for this experiment, you'll be using a bung and a nylon rope, and there's a little holder. So you put your hands here and rotate it, and when you rotate this will go around. And the tension on this bung is created by this weight hanging downwards. So it's going to cause a tension by pulling this nylon rope. And the trick is you want to keep this marker at the same place all the time while continuing to rotating this. When you keep this marker constant, you're actually keeping your radius constant. So you want a constant distance from the bottom of that holder. So you're keeping your radius constant as you're going around the circle. So the tension is provided by the weight and it's acting towards the center. So that is the one that's providing the centripetal force. So centripetal force F is equal to the tension, and that tension, because it's connected on the rope, is the same as mass times G. So note, the only thing in this experiment you're changing is your mass. So if you have these little blocks, you can put more or less blocks, but you're going to make sure that you keep the radius constant by keeping the marker same distance from the pipe, and also you will need to measure the period, so the time taken to do a complete loop. So the best way to do it is time for 10 times, then divided by 10 to get the average time it takes to go all the way around. So that gives you the period T. And you do that for different masses, so you're doing it for different tension. So now you fill in this table in your lab book. So FC, that is that force towards the center, so that is same as mass times G. Make sure if you're using 9.8, convert the mass to kilograms. And time is how long it takes to do 10 complete loops. Then you divide it by 10 to get a period. And you do it for different masses. So once you complete these two, then you will square your period. Then you do 1 over F. I'll show you why do we need to do this. So after you fill the table up, plot this against this and see how is your line look like. So carry on with the video after you've done the plotting. Also, it's really important that you keep the radius constant and also write down the value for your radius. So that's the distance from there to there. So you have these three formulas: force is equal to mass times acceleration, and we know the acceleration towards the center is v squared divided by r. So this r is the radius, so that's the one that you kept constant throughout the experiment, and v is 2 pi r divided by t. So we want a relationship between t and f, and f is measured by mass times gravity. So you substitute this into this. So v is 2 pi r divided by t. So 2 becomes 4 pi squared r squared divided by t squared. And you have r at the bottom, and the r cancels the r at the top. So it's 4 pi squared r divided by t squared. So now, from your graph, work out the gradient. From the gradient, work out the mass m of the bung. Once you've done that, take the bung and use a scale to measure that mass.